the third week, we most likely will have Pauline Jr. tackling the module that is storage. Possibly after that, we will have Albert Banda tackling databases. Then maybe Joseph Tete will handle, maybe by week 5 or 4 thereabout, will handle networking and content delivery. Most likely I'll be back here again to see you. I'll be here every weekend, definitely, but I'll be back again in the driving seat, I suppose, in week 6 or 7 thereabout to handle issues on migration and transfer, and so on and so forth, until the entire syllabus is handled end to end. And when we finish the syllabus, there is a day that Isaac and team will communicate to you that this is the last day. On that last day, we might have a class that will last for about 5 to 7 hours. So it will be a full day affair. We can have mid-morning, then we have a break, then we have lunch break, then we have, until those hours are over. On that particular day, we will handle the entire syllabus end to end in what we are calling Cloud Practitioner Essentials crash course to consolidate what we will have learned over the weeks. The mode of delivery will be, we anticipate that you are engaging with some content. Like we are hoping that at least by last week you engaged with the content that relates to what is it, to cloud concepts, such that when we come to class, we'll make best effort to complete as much as we can complete. If we can't, I will definitely share with you a handout, Isaac, and you'll give the handout to the people. It can also now consolidate the understanding even further. And then, and so on, such that if we complete today, you consolidate yourself on cloud concepts and start reading ahead for compute. Then William will be here to do compute and bring your hardest questions, and he will try to fill in your loopholes beyond just delivering. So what are we saying? We are saying that we are giving you a solid team that we have got full confidence in it, that end to end, we will guide your journey, and end to end, we know that when this is done and dusted, the AWS User Group Uganda will be very confident that their first bootcamp can end with a good number of you doing certifications. And it will not only end with that crash course. After the crash course is over, Isaac and the moderators and myself will work on a possibility of how we can support you on a basis of what we are calling exam and certification preparation, where we can do a few practice tests together to ensure that you are arriving in that exam room armed to the teeth with a solid knowledge base and some practical skill set that can enable you to succeed. I don't want to take so much time, but I want to allow my team to introduce themselves, such that in the upcoming Saturdays, when you meet with them, you will be at home with whoever is doing the delivery. And you can also connect with them online on the socials, especially LinkedIn, and we can keep on growing together. So what I want to do is I want to allow Albert Banda, you can introduce yourself, then Joseph, then Pauline, then William, and then we get this show started. Over to you, Albert. Albert, if you're speaking, you're on mute. Now I hear you. Now I hear you.
I hope I'm audible.
You are audible, loud and clear.
Apologies, my network is a bit laggy, and I can't turn on my camera due to my environment. But yeah, welcome everyone. Glad to see you here. You're in great hands. I can see my colleagues Joseph Tete, Terence, William, and yeah, I can see the full list. But yeah, welcome. My name is Albert Banda. I'm an IT enthusiast. I love technology. A lot of people know me because I make quite a lot of noise about Linux and AWS mostly. But yeah, welcome. Feel free to interact. We'll try as much as possible to make sure that you get the best training as possible. But welcome everyone. Thank you, Terence.
Over to you, Joseph. Joseph Tete. Joseph, you can introduce yourself.
Good morning, everyone. Am I audible?
Loud and clear.
Okay, so apologies for my face. It's early morning in Ghana, so it's Saturday. You can see there are very comfortable ingredients for sleepy hours. All right, so my name is Joseph Tete, and I am a technical trainer and AWS authorized instructor. So I've been doing deliveries for the past 4 years, but I have been a teacher for the past close to 8 years. So what I will do is that with all the experiences, with all the things we've learned over the years, I'll try my best to impact you with it. I think at this time we've come so far that when we say something in cloud or IT, it's like we are doing prophecy. So I would like to see you cooperate with us so that we can impact all the knowledges that we've gained over the years. The thing here is that I hope you all dedicate some time for this because it's a very fruitful journey, and I'll be happy to see you all when they tell the story and mention our names. I think it's very good when I see someone at the top and say, oh yeah, Joseph was my trainer, or Albert was my trainer, Terence was my trainer. Terence is our boss anyway. So nice to see you all. Thank you.
Over to you, Pauline Jr. You can introduce yourselves. They know you. I know you. They know you very well. You've been there. You've done that. Over to you, Pauline Jr.
Hello. Good morning. I hope you are all doing well. My name is Paulina Makira. I have been here before for a session, and I'm glad to be back. So I'm an AWS technical trainer too. We work together with Joseph, Albert, William, and Terence as our boss. I am excited for this opportunity to impact and to share knowledge. Um, I just hope that you'll all focus for these weeks that we will be together. Hopefully, you all get to certify for the first AWS Cloud Practitioner certification. Uh, you'll see me around. So back to you, Terence.
Last but not least, in the directing staff that is delivering this course is William. Over to you, William. You can introduce yourself.
Thank you, Terence and Isaac. So I'm William Koyandi, an AWS authorized instructor, as well as an AWS community builder. I've been a community builder for the past 2 years right now, and still learning. We'll be meeting in the sessions. I think I'll be taking you through the next session, which is on compute. And I'm really excited to be around, just getting to meet new faces again and impacting them with cloud knowledge. So thank you so much, and I'll see you in the sessions.
All right. So the cooperation that Joseph Jr. and William and Albert are working with have been kind enough to allow us to use this platform. There'll also be a recording of this session. And I think that recording will always be availed to our good friend Isaac and team. And we know you might need reference for what you're studying, because this, I think, in 2 or so weeks' time, that recording will be deleted. So I think that also will be made available such that you guys, if you need it for reference in your studies, you could always have it. So without wasting time, I think we've spent a quarter of an hour with our introductions and getting settled. And without much ado, I think I want to dive into the world of cloud concepts. We are starting at the very base of it all. And yes.
So for the questions, do we wait when the session is ended, or you can post the questions as you?
You can post the questions on. You can post the questions on what is it in the chat, and then we'll have a 5-minute break to handle questions on top of the hour. Then we go, and then again at the end of the next hour we can handle the questions so that we can have a smooth flow.
Okay, all right, that's fine.
Yeah, and then we will also have some other ideas concerning the future sessions, like maybe if people want to join 1 hour in advance for us to do like, you know, let's say next week. Next week, I believe next week we have William coming here for compute. But if you want to join 1 hour in advance for us to maybe do a knowledge check on cloud concepts, as well as do maybe a demo, a small lab demo on the related, we could always maybe start this earlier for those who are available. It's optional, because I know you requested for 2 hours on the calendar, but for me, where I'm sitting, I'm thinking we can add more value by maybe starting an hour early before the trainer comes in. That's just between you and me, but we'll discuss it further. So let's handle the questions at for 5 minutes thereafter. At it will be 12 noon in Uganda as it is in Nairobi, and then again we'll have questions after the next hour is over, and then we call it a session.
All right. Okay. Cool.
So the thing we can do is we can all mute our mics for us to ensure we have a very high quality recording of this particular session, and I will share my screen and you will let me know if I'm sharing. Okay, let me see. My good friend Isaac, is my screen sharing?
Yes, it is.
So we can go into the slideshow.
Right.
So, good people, our end goal is the AWS Certified Cloud Practitioner. The AWS Cloud Practitioner Foundational certification is the one we are pushing for, and it is the one we are studying for. Broadly speaking, my fellow instructor might correct me, but this particular syllabus you guys are working on came into play, I think, Q4 last year. It is the CLF CO2 syllabus. And what you will go through once we are through with the entire content, it will be 20. These are the domains. The domains we will be going through contain 26%. We will be tackling the cloud concepts, what we are doing today. And another 25%, we will be tackling security and compliance. That is yet to come. Then the lion's share of the content will be within the technology, cloud technology area, which is 33%. And then I don't want you to underestimate this particular module. Maybe my trainers will also attest to what I'm about to say. This is one of the most underestimated module by the learners. But again, it is the module where I normally record the highest numbers of. This is the particular domain where people normally record the lowest score. It's very small. It's only 16% of the content, but billing and pricing, I don't know. For some reasons, you people like technology and you hate anything relating to how we pay the bills. So anyway, end to end, everything shall be covered and you are in good hands. And that is the map, the roadmap of where we are going in terms of the exam and its domains. So when we share the handout, you will be able to look into those things from one area to another. But today, we are on domain 1, which is cloud concepts, and we are going to try to define the AWS cloud and its value proposition. We are going to identify aspects of AWS cloud economics. We are going to list the different cloud architecture and design principles. That is what we are handling today with the cloud concepts module. So do not mind this. The handout I'll give you is, I think, CLF CO2, because this is just what I would say the syllabus that was running until about sometimes September last year, I believe. So this one came into play about October last year. And we are studying for this particular one because this particular exam is no longer at play. But it does not mean that things have changed. You will see that the handout I'll give you for your own personal reading will be slightly differentiated with a few more slides than the one we are using for delivery here. Because also in class, we are constrained by just 2 hours. So there are no prerequisites. We don't care whether you have an IT background or not, but an IT background and a CS background, an information technology background and a computer science background is definitely an added advantage. So don't worry about you not having the IT and the CS background. What is happening? Our trainers will take us through this journey slowly and will build block upon block and have a solid foundation. And what are we learning today? We are going to learn the key cloud concepts. We are going to look at, broadly, we are going to look at things like scalability, elasticity, and security, but not at depth where security is concerned. We are going to look at this, and we'll need to understand what are the cloud deployment models, which are public, private, and hybrid. Some of you already know that. And then we'll also look at the service models as entailed in what we call infrastructure as a service, platform as a service, as well as software as a service. Essentially, the client server architecture is something that is very, very, very important within the cloud. And this client server architecture is such that there is also always a client machine requesting for a service. There might be an email server in our environment, our IT environment in the office. But what's happening is we, the rest who have got email addresses, we are the clients and the server is facilitating the email service for us. And that model is super important inside the cloud. So as we said, no prerequisite experience or even knowledge, and we are asking for no prerequisites at all or even any background info. Just be patient and we grow together. So there is cloud computing, and it has become very popular. Many people just call it the cloud. When people are talking about the cloud, what are they talking about? In a big way, many enterprises today, enterprises run their IT infrastructure on the basis of what we call a data center. If it's a big enterprise. If it's a small micro enterprise, maybe it's just a shop you and I run and we are doing a few operations. The so-called data center, we might call it a server room. A server room. And that server room, what happens is we locate the IT resources of the corporation or of our small micro enterprise in that server room. Now, what happens is the email server sits there. The web server that is hosting our website sits there. The DHCP server that is enabling people get addresses that facilitate communication on the network sit there. So, in the recent years, different types of corporations are migrating to the cloud. Whether it is a big e-commerce website like, let's say, eBay or Amazon.com, which was the initial one to be on the cloud, or big corporations that do a service like video streaming, let's say like Netflix, they are cloud native corporations, or even big corporations that are carrying out one service or another. I believe in Kampala and worldwide, just like worldwide, you have Uber, you have Bolt, and all these apps for hailing a cab. You'd wonder, I mean, if they had to build a data center everywhere worldwide, how big would the IT infrastructure be? It would be just gigantic. And the thing is, their core business is to run a transport solution corporation, not to host data centers and run and manage them. So the cloud has become that important, and we are beginning to see many people, not even beginning, we are at a level whereby the cloud migration is at another level. Let me give you a statistic that can encourage you to keep on studying with us. The statistic is, of all the workloads in the world, That is the workloads that have to run on the data centers, in the server rooms. Less than 20% of those workloads have been migrated to the cloud. So there are still 80% of workloads, be they compute, storage, and so on and so forth, that are still in the data centers and server rooms of corporations here on premises. So that means the scope for you making a career is very big. It's very big. It means that there's a place for you. Do you want to do networking in the cloud? There's a place for you. Do you want to run databases in the cloud? There's a place for you. Do you want to be a solution architect such that you just design solutions? There's a space for you in the cloud. Do you want to be a developer who is building maybe cloud native applications and cloud native websites? There's a space for you there. Or are you just interested in infrastructure work whereby you are a cloud engineer who does the administration and management of the various infrastructures that corporations have set up? There's a space for you. And as this adoption goes on and those migrations take place, you have a big opportunity. And this is where I want to encourage you that you are making the right choice by having this structured study and deciding to move your career towards that direction. So, from a definition point, what is cloud computing? The definition here is saying cloud computing is a remote virtual pool of on-demand shared resources offering compute, storage, database, and network services that can be rapidly deployed at scale. In that definition, I take this very important, a remote virtual pool of on-demand shared resources. And why are we just mentioning compute, storage, databases, and network services? We are mentioning that because these are the typical services that are to be found in any solution. In a soft solution, it has to have the capacity to process, hence compute. A soft solution has to have the capacity to store. I mean, after we've done this or that, we have to have the capacity to store our data somewhere, hence storage. And then there is certain type of storage that needs to be organized in a certain manner, maybe highly structured or defined in certain data structures, hence the need for database services. As for network services, connectivity runs on a network. You need a network of one kind or another to be able to connect. Like right now, I'm connected to you. You are using the Teams application where you are. I'm using the Teams application where I am. But the road that links me to you is the network services, that is the internet. So we go back to the important thing that we're saying is the virtual. One is virtual, two is compute. For some of you who've worked on what we call the on-premises data centers, you are familiar with the concept of virtual machines. We may have one bare metal machine as a server. Let's say this is our server. But virtualization as a concept has enabled us to be able to virtualize another virtual machine box over there, another virtual machine box over there, and another one here, such that this could be a virtual machine that belongs to, let's say Isaac, he's doing his work there. This one could be mine, and this one could be maybe Albert's. So you can see we have machine 1 over here, and we have machine 2 over here as a virtual machine, machine 3 over here as a virtual machine, machine 4 as a virtual machine. What ends up happening is we are running on one bare metal server. This one bare metal server is running 4 different machines. And that is the secret of cloud computing. Cloud computing in a big way relies on virtualization. So to understand cloud computing, you have to understand that its very base is what we call virtualization. And this that we call public cloud vendors, like let's say AWS being one of the very largest, or Microsoft Azure being one of the large ones, or Google Cloud Platform, or Oracle Cloud Infrastructure, or we have also Alibaba Cloud, or even IBM, previously known as the Bluemix. Today they call it IBM Cloud, or even one that is loved by developers like Heroku Cloud. Web developers, I think, love that one. For the devs in the house, I'm hoping I've not left you out. They have bought so many servers, bare metal machines, set them up in and mounted in cabinets inside their very big data centers worldwide. These data centers are as big as the biggest football stadium you can have in your country. As in, it's not only one, there are many. Maybe Isaac, you can correct me. Is the stadium there in Kampala called Nakivubo?
Yeah, we have it, and also we have Nambole being the biggest.
I know Nakivubo as one of the big ones because that's the one I knew back in the days. So you can imagine a data center as big as that stadium, and it's not only one. We're having data centers as big as that, and they are worldwide, and they are having a lot of servers all over, such that on the servers that are sitting there, virtualization is being undertaken, such that very many virtual machines have been enabled in that data center, and they are hosting one service or another. Is it a storage service you want? You'll go there and purchase that service. Is it a database service you want? You'll go there, you'll purchase that service, so long as you have an account with be it AWS or Microsoft Azure. So those are the public cloud vendors, and you should know at the base of it is indeed there's a bare metal, which is a server that is sitting inside a data center, and virtualization is being undertaken. And this virtualization is being undertaken on the basis of a software. This software, you call it a hypervisor. So we are trying to understand what is virtualization, because it's this virtualization that enables us create virtual machines. We are not going to go into the intricacies of this. Some of you might be data center engineers, or just engineers who are interacting with softwares like, I suppose, VMware, NetApp. You're interacting with softwares like Citrix, EMC. Those are softwares that help you do a lot of virtualization, and they rely on what we call a hypervisor. It's on the basis of a hypervisor that, you see, this was the bare metal machine. This is the bare metal server. But as we were saying, maybe we are running VM1, VM2, VM3. We are just going to the base and understanding, okay, what is this that AWS is doing to be able to give all these people the services it gives worldwide? It is virtualizing. And it sets up multiple virtual machines. And you see, when a virtual machine is running, of course, we have an operating system over here. But each virtual machine believes that, of course, it's taking a time slice. All these virtual machines are taking a time slice of this particular operating system. But each one of us and our virtual machines, we do believe, we are stupid enough to think that I am the only machine here with my own operating system. Same to this one, same to this one. Hence, it ends up that we are now running 4 compute machines as opposed to the one original one. So that is the importance of virtualization in setting up the cloud. So, as I was telling you, it runs on the basis of what we call a hypervisor. So it's on top of that hypervisor software that this hardware is able to virtualize those virtual machines, 1, 2, 3, and even more. And then on the basis of those virtualized resources that are virtual machines, we are able to host many services. And on the basis of the same, we are able, relying on various data centers that are in what we call the AWS global infrastructure, to reach to the farthest and widest audience of clients who want to consume one service or another. And that service may be a compute service. That service may be a storage service. That service may be a database service. That service may be an artificial intelligence service. That service may be a business analytics service, because this is making life easier for corporations. Now we do not have to set up a very big data center or even set up a very big server room on our own premise, because what we do not have on premise, we can now go buy it on a public cloud, whether it's Azure, Microsoft Azure, or AWS, or Oracle Cloud Infrastructure, or Alibaba Cloud, whichever public cloud you prefer. It's just that our public cloud of interest here is the AWS that we are studying. So, what are the benefits of this virtualization? We can see that one, reduced capital expenditure, that is CapEx. Take note. Those are things you'll be asked in your upcoming exam. Another thing is reduced operating costs. Then your carbon footprint also lessens. You know, do not imagine that when these data centers and and server rooms are running, it's for free. No, it's not. You are paying electricity costs, and that electricity has been produced in one way or another, maybe burning fossil fuels or using solar energy or hydroelectric energy, and so on and so forth. So when we leverage on the public cloud, we reduce our footprint. We have a smaller footprint such that lesser resources are being used in terms of even housing and spacing. But even as less resources are used, our business becomes more green in terms of operations. That is, we are not polluting as much as we would have polluted with having our servers running 24/7, 365. And then there's also optimization of resources. So in a cloud environment, everyone can benefit from virtualization, from the cloud vendor to the consumer. From the vendor side, they're able to sell us even more services as they virtualize more. Whereas we, as the consumers, we will look at what are the consumption modules and how is cloud consumed compared to undertaking capital expenditure of setting up an entire data center or setting up a server room. So we've already talked about virtualization. And whereas on your own laptop, for example, you will call it a virtual machine, typically this virtual machine in the cloud, you'll hear us call it an instance. So much later on, you'll hear the instructors tell you instantiate an instance. It's the same thing. The virtual machine is just an instance. So what are the typical services? The typical services that are used are essentially compute, which is processing power, storage, which if we want our data to persist, databases, which is still storage, but in a structured manner, networking, which deals with connectivity and content delivery. Then in the recent years, not even the recent years, just the recent days, this is becoming a service that people are really consuming a lot. Machine learning, as well as artificial intelligence. Maybe the assignment I should give, Isaac and team, you guys can tell us what AWS services deal with machine learning and artificial intelligence. Now that this is the rage, this is what people are talking about. But the other people who also been very powerful in machine learning and artificial intelligence, like back in the day when I was fooling around and learning cloud, the Google Cloud platform, I remember one very powerful ML and AI tool, they call it TensorFlow. I think some of you have used it to analyze data. Back then, I was just a university student, and I never imagined this would become as important as it became. I was just fooling around and toying around. But look at where we are. And these are not things you can afford on your own very easily. But if we are leveraging on the public cloud and you're just paying for it there on the public cloud, you are in a good space because you just pay for as much as you consume. But setting up your own, let's say, high-performance cluster machines in your data center, and then you're able to set up a machine learning or an artificial intelligence service would be very costly. So we carry on. Compute. We go to the compute. It's essentially the brains of what is happening. It's the processing power. So being the processing power, we have indeed virtualized and we are now consuming compute from the cloud. But it is not any different from what is happening on your laptop or my laptop right now. It is just virtualized capacity for the central processing unit as well as the memory. But now we are buying it from the cloud. All I want you to understand with the cloud simply undertakes software and it defines it through virtualization. So that particular power that you wanted, that is compute power, you can now still also purchase compute power for your servers or your instances, in this case, from the cloud, and then process your workloads. Then we have storage. We have situations whereby we want data to persist. We, on premises, in our data centers or in our server rooms, we used to set up things like network-attached storage. Some of you who are engineers already understand that. Or we used to even set up storage area networks. And I'm sure some of you have interacted with solutions on premises, like let's say VMware storage is used in many corporations. I think they use a particular storage called solution called vSphere. Or even some of you may have worked as engineers on premises and you've seen storage solutions like NetApp and so on and so forth. But that very, very same storage that you have on your hard disks or your solid state drives inside your data center, or even on your laptop, or even on your workstation, or even on the limited server, bare metal machine you have, can still be purchased from the cloud. Then we have databases. And this one is very much where we are dealing with structured sets of data. And the typical databases are databases like Oracle, very popular in the finance world, in the corporate sector. Some of you open source developers, I think you've used MySQL database. Microsoft has got SQL Server, which is also popular in the enterprise world. And the same can still be purchased in the cloud. Then we have networks. For you and I to be able to communicate like we are communicating on Teams, I have my endpoint and I have the Teams application. You have your endpoint on the other end, you have the Teams application. But there's a network. There's a road between you and I and this communication that we are having, that is the network. And in this case, we are leveraging on the public internet. So my internet service provider has given you bandwidth, same to yours, and we are interfacing with each other. This networking in a typical server room or data center used to run on the basis of, let's say, routers and switches. And therefore, it needed even security from things like firewalls. And I can see nowadays they've advanced in just beyond them allowing and denying traffic into your environment. They have become sophisticated and do far much more. And those hardwares, I think you're calling them next generation firewalls. Huh? Some of you who are engineers, you've interacted with the likes of Fortinet, Palo Alto. I think where switching and routing is concerned, the likes of Cisco devices are popular, same to Huawei, same to Juniper. Who else? I'm sure you people know others. Like you, Isaac, you are in data centers in a big way. I'm sure what I'm talking about is not alien to you.
Sure, it's not alien.
So these same hardwares that you're having in those server rooms, that you're having in those data centers on a basis of virtualization can also set up maybe software-defined networking for you, but in the cloud, such that we can set up the same constructs, but in the cloud. That very data center you are setting up or that server room you're setting up can be set up inside the cloud as a VPC where AWS is concerned. I think in Azure, they call it a VNet, a virtual network. So we go back to that definition. What is cloud computing? And we say it's a remote virtual pool of on-demand shared resources offering compute, storage, databases, and network services that can be rapidly deployed at scale. So you are seeing the role of virtualization in setting up those services. And we're just mentioning compute, storage, databases, and network services, so that those are the typical services needed when you are having a typical solution. But it can be more. There can be business analytics services. There can be artificial intelligence, as we've seen. There can be machine learning, and so on and so forth. So we complete one aspect of what we were studying today on, which is the introduction and the basis of cloud computing. And now we are going to look at what are the cloud deployment models. There are different ways we can consume cloud. And this is where deployment models come into play. So what about the cloud deployment models? We have three typical cloud deployment models, whereby we have the public cloud, we have the private cloud, and we have the hybrid cloud. These deployment models, you choose which path you want to take to the cloud. Yes, people are migrating to the cloud, but your bosses might ask you, hey, we have heard there's this great thing called the cloud. What about it? You have to let them know that it's not one size suits all. Based on the analysis you do of your requirements, you might choose one deployment model over the other. And we are going to look at these deployment models at depth. So what about the public cloud deployment model? This one leverages on a vendor. And there are many vendors. We don't only have AWS. We have said that Microsoft has got Azure, second biggest cloud in the world. We have said that Google has got the Google Cloud Platform, that biggest cloud in the world. We have said the Chinese have got a public cloud, Alibaba. Originally, Alibaba was just like, let's say, the Amazon.com of China, isn't that so? But today they also vend what is it, Alibaba Cloud. Then I think there is, today you call it the IBM Bluemix, previously Bluemix, but today you call it IBM Cloud. I think even Salesforce that sells a CRM, they've got a very big cloud. And many others, even Huawei has got Huawei Cloud, and so on and so forth. So when you are going public and you're using the public cloud, you are essentially buying your cloud from one of the vendors. And typical services that they sell you include compute, storage, database, working resources. You can have AI and ML services. You can have business analytics services. There are so many services. At this point in time, I think AWS has got close to 250 different services on their cloud on sale. So it's you to open an account and consume whatever service you want to consume from them. And then your monthly spend, what you spent at the end of the month is what you will be charged. I want to bring a certain story into context. Isaac, at least I know you, you are an infrastructure guy. Eh?
Yeah.
I want you to tell us now, what is the typical timeline? Let's say I am MTN. We have MTN there in Uganda, isn't that so?
Yeah, we do have it.
Let's say I am MTN and I want to set up a bare metal server in the data center. I'll definitely have to release to the distributors and vendors a local purchase order, isn't that so?
Right.
Then we will see who gives us the best quote and we go with whoever has given us the best quote, isn't that so?
Yes.
Then the person who gives us the best quote will one day deliver and we pay him and then we go to setting up, isn't that so?
Yes.
Then when this thing has been delivered, we paid him, we will put an operating system on that particular bare metal machine. Then we will configure it for our network in the data center. Then we'll mount it on a rack inside the data center. Isn't that so?
Right.
Now, Isaac, tell me, in Uganda, based on your experience as an engineer over the years, starting this process from here where it starts to when that machine is up and about, how long does it take? How many days? How many weeks? How many months? How long does that take? That finance have said, hey, you guys, you can have the money. Here's the money. Put out an LPO, to you racking that inside the DC.
I think from the words, from the initial engagement with the finance team, then approving the LPO, then to giving to the vendor, it's maybe you can give it 2 weeks.
2 weeks. And then how long will the vendors deliver?
It depends. Let's say within 4 to 5 days.
Okay, that is if the machine, the specific server machine we want is in Uganda, isn't that so?
Yes. But
So that we're already counting, we are on week 3, isn't that so?
Yes.
And then when this person delivers in our office, and then it's given to your people, and the data engineer or the system administrator or the systems operation person has to configure it, put an OS on it, blah, 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 licenses, operating system, then go rack it inside the data center. How long should that take?
We'll give it 1 or 2 days, 2 days at most.
So you're saying in the list we need 3 weeks?
In the list, yes.
But averagely, if we make a typical worldwide average, it's like 6 weeks. Because Uganda is different from Kenya and is different from Rwanda and is different. So let's say within 6 weeks, we can have this thing done and dusted. Eh?
Yes.
In the agile environment corporations are operating in today, do you think a corporation, let's say on our e-commerce website, there is heavy orders coming. The orders are about to break the internet. Do you think, and that is happening today, for some reason, Ugandans woke up and they want to buy iPhones on our website like you can't imagine. Maybe we had a successful marketing campaign online last week. And then today, we have 500 orders for iPhones on our e-commerce websites. And you know what? The Ugandans they are not even knocking. They are kicking and screaming at the door. They want those iPhones like a nonsense. Do you think those Ugandans can wait for 6 weeks for us to set up a server to manage that workload?
No way. They'll get alternatives. They can't wait for 6 weeks.
They can't wait. The orders are coming in today and they want the delivery within the next 2-3 days. Do you think they can wait for 6 weeks?
They can't. They can't wait for the 6
No,
weeks.
they can't. You know what will happen is that workload will break that. I mean, the website will break down. Isn't that so?
Yeah.
But you and I setting up maybe 5 other extra virtual machines with that server instance to hold that workload. Let's say in like 5 to 15 minutes, we will be having maybe some virtual machines sitting behind an auto-scaling group and handling that workload like nothing. So are you beginning? I was just trying to bring into context. Are you beginning to see why many people are opting for the public cloud? Nobody can afford to wait for 6 weeks when they could have made money like yesterday. So that is the value proposition where the cloud is concerned. They will set up the virtualization as AWS. They will avail those services across the entire AWS global infrastructure. And for you and I, is just to go there and instantiate as EC2 and be able to run whatever. I mean, maybe it's our e-commerce website or it's a particular web application. And that can be done so long as our code is there, upload it there. It's done. And let's say in 5 minutes or in 15 minutes, we are up and about and we are coping with the workload that is coming against us. And we do not care about what is happening with the backend and physical maintenance of those servers, their power, their cooling, because we are leveraging on the AWS global infrastructure and their data centers in the various geographical regions. So long as we have an internet connection and we have an AWS account, we can access that extra resource that we want, whether it's compute or storage, and so on and so forth. So that is the case of a public cloud vendor. With a public cloud vendor, so long as we have our account and we are consuming whatever services, we can pay the pay as you go. I mean, we can just pay for what we consumed last month at the end when the monthly spent bill comes. Then there's a case of private cloud. We can't virtualize on-premise, just leveraging on our own data center or on our own server room. We can't virtualize a cloud there. I remember once upon a time, many years ago, when I was a field engineer, we had our own big data center. And we used to have what we were calling co-location services on that data center. But it was our private cloud for the corporation I was working for. And it could, actually, this company I'm talking about, strangely, Albert, it's an, not Albert, Isaac, it's an Indian corporation, but it's of course, it's an Indian corporation, but the Africa HQ for that company I worked for is in Kampala. I don't know if you have friends who work at Sibyl. You have friends who work at Sibyl?
Yes.
So once upon a time, I worked at Sibyl, and Sibyl, Nairobi, we had a data center. And in that data center, we were virtualizing a private cloud in it using NetApp, VMware, and so on, Citrix, EMC, and so on. And we were using it for our own purposes, our own engineering purposes, but we were also selling that cloud. We were also selling that cloud to other corporations in Nairobi that do not have adequate capacity in their own data centers. And even some other people were co-locating, like their disaster recovery services in our private cloud, and we would give them a monthly bill for them to pay. So this is a situation whereby you virtualize the cloud for your own use so that you have your own control over it. In the case of Sibyl, as I'm talking about them, they were also doing co-location for other corporations in their private cloud, and they were also selling extra compute power, extra storage. If you do not have extra storage as a bank, you would come and buy it from us. So that's the case. This is privately owned. Now, like that cloud was owned by Sibyl as a corporation, and it did with it as it so pleased because it wanted control over it. Then the last of those is what we call a hybrid cloud. And a hybrid cloud is a mix. It's at the intersection of the public and the private, and it's a mix of the two, whereby there's some mission critical data that we do not want to put up in the public cloud. We really need it in our data center. But there are certain subsets of our data maybe we want, or of our operations that we want to run in. So we have a mix. We have our own private cloud running some things of ours, and especially when it comes to test and development environments, you can have a situation whereby there are certain workloads. This is the public cloud, this is the private cloud, and you are there's some work that happens within the hybrid cloud, such that if we do not have adequate storage capacity, we can burst into the hybrid cloud and use it there. Or if there are some temporary workloads that maybe cannot run here, we can buy the extra capacity from the public cloud and run it there. So Isaac, we are at the halfway mark. I wish to tentatively stop here for about 5 minutes, and then the trainers who are on the bridge, as well as myself, can respond to any questions that can arise. So maybe it is for you to bring up the questions for the next 5 minutes, and then we again start running to the finish line. But for now, what you can do is you can also get yourself a glass of water. You can also get yourself, like myself, I love tea. My trainers know that I love tea. There's definitely always some tea to energize me, and so on and so forth. But the questions can come in now that we are at the halfway mark.
Okay, there's some questions in the chat. Maybe I can run through them. The first one, it was posted by me. So how can you explain cloud to a kid, basically? A kid, it's a 5-year core, a kid also in the same line.
Let me make a joke. That one, I love it. I want to make a joke.
Okay.
It's a typical IT joke. Now, explain the cloud to a 5-year-old kid this way. The cloud is a computer. It is just somebody else's computer that you are hiring. Joseph, am I saying the right? Joseph Tete, you can help me. This is an IT joke, but I think there's a lot of truth in it. The cloud is just a computer like any other. But in this case, you're just hiring somebody else's computer and he's making you pay for that hiring at the end of the month, period. Let the child understand it that way. So Joseph Tete, you can help me. You're one of the teachers here online. Yeah. Joseph,
I think Terence is pretty right. And we can also just think of today what we are doing. You see people using Uber, Lyft, and stuff like that. So how do you know? Here we are trying to bridge that gap of what you said, when it takes about 3 weeks and a lot of money to get your own infrastructure. So we are just renting someone else's infrastructure. Like you want a car to go to a place, you just pick an Uber. Yeah, you are just renting someone's car. It's the same thing with the cloud. So for me, the best way to kind of make a 5-year-old child understand it will be, okay, we play games, so pick their favorite game. The game needs to reside somewhere for them to play it. And the company that gives them the game to play needs to have very specialized infrastructure, which is very expensive. So to prevent that, they decide to rent other organizations' infrastructure to put their applications on so that they can play with it. And now that has been decentralized. Everybody at all can have a data center resource to use.
I'm hoping that has made sense. And I also like using Uber. I really like, like Nairobi is a nightmare, some traffic days, in the sense that, and even if I went with a car to town, there is issues of, what do you call it? Where do I park? Maybe I'm having a full day event. So it makes so convenient for me to use this transport solution. Somebody is already solving my transport solution. I take an Uber, I get to town. Wherever he parks is his headache. What his fuel cost was, that is his headache. For me, I paid for just precisely moving from point A to point B. And this is the strength of the cloud as a value proposition. We only used this compute. But can you imagine, Isaac? On-prem, we set up that particular server. Do you know we went to Microsoft to buy an OS? Cost us more money. Not that that will not cost us on the cloud, but in the cloud, the cloud is not buying to own. It is using to rent. We only pay a monthly spend for what we used.
Yeah.
Any other questions as we wind up the break period?
All right, there's a similar question from Darius. It says, imagine we are in the year 1902. How would we explain computing to a person? So we're taking it back in the years. Imagine you were in 1902. How would you explain cloud computing to a person in that year?
Oh, because you see, with 1902, we are thinking of a place where even computing had not advanced to the levels we are. This particular level we are in, and things like the von Neumann architecture coming. Von Neumann, he came from, where do we call it? He came from Hungary, and he ended his career at, where is it? At Princeton University in the US. Now I'm speaking as a computer scientist. He gave us what we call the client-server architecture.
Right.
So 1902 computing was at its very elementary level, and maybe the most complicated computer in 1902 was tending towards a calculator and something that can do 1 + 1 is equals to, and so on. So I'm struggling really in my mind, based on the background I have in CS, to say, hey, if I was in the time machine, it took me to 1902, how would this be? But Joseph, help me up. You had your hand up, and then Ray, you can also pick. Ray Carl, you'll pick.
I think I want Ray to go on first. So Ray, come in, then I follow.
Thank you very much. My name is Raymond. I'm an electrical engineer, but I am not allowing the tech revolution to leave me behind. My question is basically, what is the value proposition for local industry players like Raxio, in reference to the very advanced services that are offered by the big players. What is the value proposition, and what would be those points for which you would choose a local solution over an international player? Thank you very much.
You see, for me, I'll say the technology has democratized things. I don't want you to talk local. I don't want you to talk global. You see, you today have the opportunity to do something that people did not have a long time ago. Like, let me ask you, these people who say they've generated generational wealth and maybe their family is a billionaire family today for over the 100 or so years. The question to you, Ray, would be, when was Uber founded? Not more than 20 years ago. Isn't that so?
Yes, sure.
When was Netflix founded? Not over 20 years ago. Isn't that so?
That's right.
And very many other innovative services that you are using. For me, I think the value proposition is innovation. Your ability to leverage. I used to read certain books and I really loved them. Let's say books on finance and stuff. And before technology, for us to build a $1 billion corporation, let's say a corporation like IBM has been in computing for the longest time. Can you imagine how long it took IBM to make their first $1 billion USD? I mean, IBM is more than 100 years, international business machines. But how long has Facebook been there? It's not been there for like, let's say 50 years. But the modern day technology and even cloud, you know, Facebook is running also on, I suppose they've got big data centers, therefore they're running their own private cloud. So how long did it take IBM to make their first $1 billion? Even this Amazon.com that ended up turning their IT department into AWS. You know, AWS was originally just an IT department of Amazon.com. Huh? So how long did it take AWS from the year 2006 to being the multi-billion-dollar entity that it is today? I mean, to make their first $1 billion. What I'm saying is innovation, leveraging on innovation, you can go very far. So they are business modules that were previously not possible. Uber does not run even one data center worldwide. Isn't that so? It's a cloud native corporation. They are hosting this Uber application that is very lovely on the AWS cloud. Isn't that so? And
yes,
can you see, Uber is not even 30 years old, but how long did it take them to make their first $1 billion? Or this weekend, you'll be binge watching Netflix. It's a cloud native corporation. They don't have even one data center worldwide. They have set up an S3 bucket. They have loaded all those movies you love there in the S3 bucket. You stream from an AWS S3 bucket every weekend. How long did it take Netflix to have their first $1 billion in revenue? A very short time. So the innovation has also cut the time to market. As in, this technology, you see, even you as startups, actually it is you startups and you small corporations that actually drive innovation. Have you ever wondered, why is AWS buying startups daily? Why is Google buying startups daily? Because you are risky. You as a small entity, your risk margin is small and you can go try out something very weird on the cloud. And then you're like, yes, it can make money. But tomorrow Google will come to you and say, hey, give us that company of yours or a stake of that in that company of yours for 10 million USD. Because you went and tried out something that they as a big corporation cannot try out, but because of cloud, you know, there are things you would never have had. Like me, let me ask you, 20 years or 30 years ago, the most virtual machines you and I could have, Isaac, were just 1 or 2 on our Windows machine. Isn't that so? But today, how many virtual machines can I run for a few cents, US cents on my AWS cloud? Very many, and I don't care. Those were opportunities for innovation that were not there. So I'm willing to bet that the innovation quotient that is possible today is higher than in the previous world. So corporations need to wake up, and even the smaller corporations wake up even more and do even more risky experiments on the cloud, and it will pan out right for them. I think, Joseph, earlier on you had your hand up. I don't know, Ray, if you are still having another question or, but Joseph, take it.
Yeah, so Terence, I think this is a very good question from Ray. And you know, we were already talking about the 1902 things. For instance, let me just touch on a little bit on the explaining cloud computing to the 1902 people. I put an image in the chat. It was a car. That is the best car in 1902. And that photograph was taken there. So you can understand the technology they have. In 1902, electricity was just invented. Mobile phones was, not mobile phone, telephone was just invented, and it was as huge as a whole house. Computers are very, very non-existent. But we can explain it in future terms, that in the future, like how somebody was able to say, okay, in the future, we can carry our phones. When you say in the future, you can carry your phones, everybody thinks like, oh, that is not possible. Okay, in the future, we can have, everybody can own a car. So it will be difficult to go in there and say, okay, explain a data center as it is today to them, but you can explain to them in the future tense. Now, Ray mentioned something about the value proposition for cloud. Now, cloud, let's not think of it as a competition. Let's think of it like a solution, a tool to provide solutions. So as we are here right now, we are using cloud. Who knows what tool we are using in the cloud right now in this meeting? Anyone at all? What tool are we using in the meeting right now? Okay, I couldn't hear you, Mike. Here there was a lot of background noise. Okay, so we are using Microsoft Teams right now. Everyone in here is not in the same physical location, but we are making use of what? Cloud resources. So the value proposition here is that you have what we call agility. You can easily deploy resources, deploy applications without owning a data center. And you can deploy them anywhere in the world. So for instance, if I want to deploy a particular application and I want to target China, I want to target India, because of cloud computing, I can easily deploy my application in China. Okay, maybe I want to take advantage of their population. 2, it is cheaper. You see, when we were talking about buying a machine, you purchase that server and then you use it, and for the interim, you pay the full amount of it. What if you don't need tomorrow? But with cloud, you only go in and you need a server to use for 10 minutes and you go and use it, and you only pay for 10 minutes. So it is cost effective, like using Uber. You don't buy a car to drive. You just sit in a very comfortable car and you pay for the minutes or the distance that you've traveled in it. So these are the value proposition, and there are a lot of reasons why we are all moving into cloud. Now, when you are a local vendor or you are a local startup, it will be better for you to also make use of these technologies to provide the solutions. Because I don't know, in Africa here right now, any company currently have the resources to have 200 data centers globally. You get it? So there is no competition here that, okay, there is a local vendor who is providing cloud services. In Ghana, this happens a lot. Our government have their own private data center, okay? And when junior secondary students complete their examination and they want to progress, the government release data for them. And you know, the day that information, that website is released, you cannot access it. People will spend the whole night trying to just upload or download their results. You cannot, because they don't have the capacity to be elastic. They don't have the resources. So they can only serve few customers at a time. So we suggested use cloud so that you can grow and then you can shrink and there will be fluidity. Thank you, Terence. I can go on and on and on and on.
Okay.
The cloud is interesting.
Isaac, we get back on track with the rest of the class now.
Sure.
Okay, let's run into what is remaining, and we call it a day for today. So we have talked of the three models. That was public, that was private, and hybrid. And these are the deployment models. Now, we want to go into, don't worry about some of the content because this is just a 2-hour class. When I give out the handout to Isaac, it will be shared to you all. And for your personal study, you can get into the nitty-gritties. So we have wound up with those, sorry about that, these deployment models. And this is coming in your CCP exam. You must know to differentiate. At this point in time, we are dealing with especially name and identify. We are trying to build a knowledge base on what cloud is and AWS public cloud in particular. Going forward, our discourse will be heavy towards the public cloud, and our cloud of concern is AWS. We will speak much less on private and hybrid. So we come into the module that is key cloud concepts. Guys, be very keen over here. Be very keen over here because there's going to be questioning coming your way. The examiner at CCP level loves this module. And what about it? The cloud has got a number of key characteristics that allow it to be a powerful service that it is today. And you must know this inside out because this is the underpinning theory on cloud. 1, on-demand resourcing. 2, scalability. 3, economy of scale. 4, flexibility and elasticity. 5, growth. 6, utility-based metering. 7, shared infrastructure. 8, high availability. And 9, security. You must know all these concepts because they are going to feature very heavily, and these are the underpinning concepts that relate to cloud. So we go to the first one, on-demand resourcing. When we are talking about on-demand resourcing is, you need storage. You consume storage here and now. You need compute power. Okay. Maybe the website is running on a 4 GB machine. The instance we had instantiated has maybe 256 hard disk space or even SSD, and it has 4 GB RAM. On the cloud, they are just on the fly. We can increase that 4 GB RAM to 16 GB, and we can increase that SSD space from 256 to maybe 512. And we might take it from maybe an Intel Core i9 CPU and put there a Xeon processor, a more powerful processor, on demand, there on the spot. You know the things that, I mean, those are the things that you actually get on a bare metal machine. So those are the things that our good friend Isaac was telling us. This could take you 3 weeks. But here it is, we are getting it on demand. In less than 5 or 15 minutes, we get it. I'm requesting the individual who has the mic on to mute because it will affect the, what is it? It will affect the recording that we will be having. If you have your mic on, just mute so that we do not give people a bad video record. The people will be making reference of this particular, what is it? Of this particular session. So we were talking about on-demand resourcing. Then it is almost immediately available, whatever resource it is. So there is no local purchase orders. There is no wait, I mean, some lead time for us to wait. There is no, okay, the server is here, now put on it, install on it maybe the operating system. That might take another 2-3 hours. Okay, has the cabling been done and has it been configured for the network now? Mount it on the rack and then, no. It is here and now. Then Another place where the cloud shines is on this second bit of it, scalability. Sorry. On scalability, I do believe the cloud shines a lot. And this actually is relating to what I was saying, that in this previous place, when we say on-demand resourcing, yes, on demand, you can consume the service. But upon consuming the service, the monthly spend, a charge will be sent to us and we'll pay that monthly spend. But let's go back to that scenario that Isaac and I were struggling with, that our e-commerce website, for some reason, maybe has received massive orders. Everybody's buying his girlfriend an iPhone, whatever. And nobody wants to be left behind. And we were maybe running on one instance. You know what? That one instance that cannot cope with the workload, we could set up an auto-scaling group with hosting that website such that this ASG now is sending the workload to these 5. And these 5 instances, and now we are able, our website that is now hosted on those 5 instances can respond adequately. You've ever heard of situations whereby the orders or the requests, like, you know, our good friend, Joseph was telling us that the examination board has released the results. Every student around Ghana wants to see their results. Do you know what happens by the end of that day? By the second hour, the website cannot give responses. It slows down. By the third hour, when every other student in Ghana has woken up, that particular single server machine that was receiving those requests packs up, and there's even now no website for us to pick results from now. But the cloud will enable us to have auto-scaling. We can scale out to these 5 instances and deal with the workload. But on the day that everybody is through with, we can stop or even terminate the extra capacity and only pay for this one. And only pay for this particular one that is up and about in off-peak hours. So that is one area, ability for you to go up and down and in and out. And when we talk about up and down, it means that maybe this up and down story where the scaling is concerned is maybe we had 4 GB RAM. Let's say we had 4 GB RAM on the EC2. Then we increase it to 16 GB. That is scaling up. Or we had 16 GB and we reduce it to 4 GB. That is scaling down. Whereas scaling in and out is like this example where I was saying the workload became heavy and we had an auto-scaling group. It scaled up to, it scaled out to 5 instances. But again, when we are off peak, it terminated automatically for us. Isaac, I put it to you, doing all this practically and not in an automated way in a data center is a headache to the engineers. Isn't that so?
Yeah, a terrible headache.
It's a terrible headache. Like, okay, now we are off peak. You guys turn off machine number 5, machine number 4, machine number 2, machine number 3. Okay, somebody has to run from their home right now and go turn them off. Isn't that so? Go to the data center and practically turn them off. But with an auto-scaling group, it can even sense that, hey, the workload has lessened, automatically terminate those other instances. So scalability. Another thing is economy of scale. Let me tell you something. Isaac, I tell you, in the global infrastructure, AWS has got hundreds and hundreds and hundreds of data centers as big as Nakivubo Stadium.
Okay.
Therefore, it's buying a lot of bare metal machines from Lenovo, IBM, Dell, you name it. Any of these OEMs, the original equipment manufacturers, it buys. So in a year, you think, let's say, whether it's Azure or GCP or AWS or any of these public cloud vendors, in a year, how many servers, just hardware pieces, do you think they maybe buy from, let's say, Huawei, for example?
I think many.
Very many. Isn't that so? And then when you buy very many, Aren't you given a discount as a big client?
Yes, you are.
Now, when you're given that discount and you go set up business, does it make sense why the AWS services are cheap? Like maybe I can set up, if I were to check the EC2 I'm running today, how much it consumed, AWS told me that we only used 20 American cents today. Are you now understanding why those prices, why sometimes those prices are very cheap?
Yes.
In June, I had an argument with one of my colleagues. It was a fight. Nobody wanted to pay the bill. That bill, why I did not want to pay it was because I'm not the one who's running the machine so that machine put up a bill of $7. I refused to pay. Then again, in July, it also put up another $7. And what happened is AWS sent us the bill in June. We refused to pay. He did not want to pay. I did not want to pay. Then again in July, another. I was like, no, this is not. So do you know what made us pay, or what made me pay was because we were sent a warning letter. You guys, if you don't pay this $14, the services have been suspended. So you were told the services have been suspended, and then it was like it will only be resumed if you pay. And then what happened is, indeed, it was suspended and we could not use the account, but I needed the account, I think, last week. And then I saw another email. If you don't pay by 13th August, we will shut your account. So I said, what the hell? I'm not the one who used this $14, but just let me pay. I mean, I still need this account for this and that. But can you imagine? It is an EC2. It's the one that ran this charge high, but it's only $14. Now, you remember that server that I requested you to set up, Isaac? I mean, the bare metal machine that we said, okay, we are maybe buying a Lenovo hardware and then we want to put our software on it, blah, blah, blah. In terms of Uganda shillings, how much would that operations cost? Setting up that entire thing plus paying any engineer, etc., how much would that cost?
I don't cost much. I don't know how much, like what figure, but it will be a lot of money.
It will be a lot of money. Here in Kenya, if it was Kenya shillings, I don't think I'm spending less than 2 million to bring a good server into the environment.
2 million.
And we're going to put an operating system on it. We are going to enable license on it and then put whatever applications we want to run on that server. But can you see the monthly spend I'm having? Honestly, even I, who could not afford this for an on-prem data center, can you see? I can just pay $14 and I don't care. I move on with life.
Yeah.
So are you beginning to see that AWS buys a lot of these things and then the original equipment manufacturers discount them heavily because AWS is a good client for them? Isn't that so? And yes, by extension, the prices that AWS is extending to you because of having bought their equipment at a very big scale, it's also extending to you very competitive prices. So it makes sense for small players like me to hire capacity as opposed to buying capacity in order to own that capacity.
Okay.
Especially startups. You know, are you beginning to understand why all startups are running on GCP, on AWS, on Azure, they never set up any data center of their own? Is this now beginning to make sense?
Yeah, they don't.
Then flexibility and elasticity. So you can choose the amount of resources you require, how much and how long you want it, and at what scale. That is flexibility that we do not have if we bought a bare metal machine and put it up in our data center. Whether we are using it or not, it's consuming resources. The only thing we could ever do is just turn it off. But turning it off again can be very, very risky because there are other people who are using certain aspects of it. Or turning it off and it was hosting our website. That means that our website now is offline. So it means when we go on the weekend, even our website goes on weekend. I mean, does that make business sense?
It doesn't.
It doesn't. So are you beginning to see the cloud's value proposition where flexibility and elasticity is concerned? Then growth. So from that previous, it's elastic. It's elastic. And by it being elastic, it's like a rubber band. Let me just make the practical example here with a rubber band. I have one. I'll come back on video. The cloud is elastic, and that makes it super powerful. So let me just come back to you on video and have an elastic rubber band. So here is a rubber band. Here is a rubber band. It stretches out, isn't that so?
Yes.
It stretches out, hence it has got the elastic property. That is, if you want more, the cloud will give you more. If you want less, again, the cloud will stretch back in.
Stretch back.
You cannot talk about that in your on-prem. On-prem, we have 10 servers, they are 10, they're just there. Or we have to wait for another 3 weeks for the local purchase order to be put up for us to bring in a new resource onto the environment. So that is part of the strength of this thing we are calling the cloud. As in, our growth will not be constrained because cloud computing offers your organization the ability to grow using a wide range of resources and services. And this wide range of resources and services is very much unlike. I mean, there are certain specialized services, like let's say we have our friend in Malawi, Albert Banda. Sometime mid last year, he was doing training in Malawi for the Meteorological Department of Malawi. And you know why the Malawi Meteorological Department of the government was going to the cloud? They are going to the cloud because they were setting up high-performance cluster machines. Can you imagine how that would cost you if you have to buy physical servers to set up such a thing? That's crazy money. I mean, only very rich corporations. And you can imagine even that training that Banda was doing in Malawi, it's not that those guys were paying for it. The people who are paying for the Malawi Meteorological Department to have those high-performance cluster machines was the World Bank.
The World Bank.
It was the World Bank that was paying for them as a donor. But you see what's happening is, if they went and told, hey, government, we want next year for our budget, you give us a budget to buy high-performance cluster machines. And then they're told, how much will that cost? They say, I think Huawei is giving us the best price, $5 million US. Which African government will look into that? Most of the ones I know will tell you, hey, come back when you're serious. Huh?
Definitely.
But can you see, for a fraction of that amount, they could go to the cloud and set up their HPC cluster. And for that reason, Albert was there to teach them how to use a HPC cluster. So you see that growth is one thing that actually the cloud allows. And for very serious reasons. I mean, AWS already bought those machines from the original equipment manufacturers at a very large scale and at a very big discount. So for them to come and set it up for that to be set in your environment and you only pay for when you use it during the month, you pay just a few hundreds of dollars per month. And that now makes business sense for a department like, let's say, the Malawi Meteorological Department. Then utility-based metering. This is very important. In AWS, you only pay for what you use. Let's say you and I had set up an EC2. You know what will happen? Tonight, if I'm not using it, we stop it. Or if we know we'll not even use it next week, we terminate it entirely. But you know, this is only charged for when it's running. Only when it's running is when we are charged. But when it's not running, we incur no cost. Are you now beginning to understand why the cloud ends up being cheaper compared to us setting up a bare metal machine in the data center?
Yeah. So
the monthly spent, you see that $14 that me and my colleague were arguing about from the past 2 months. It's what we spent, and it's what we owe AWS, but I don't want to pay, he does not want to pay, but that's what we spent. But can you imagine if it was the costs of our own bare metal machine in our data center? How much power has it consumed? How many times has the maybe system admin logged into it to do this, to do that, relating to its administration? And that system admin, we still pay him a salary at the end of the month. Isn't that so?
Exactly.
So the cloud does take away these complications. Then there is shared infrastructure. Why? Virtualization. You see, the minute we are virtualizing, there is Isaac's virtual machine on this bare metal machine. There is Joseph's virtual machine. There is mine. So that shared infrastructure, do you realize Isaac is paying a monthly spend? Terence is paying a monthly spend. Joseph is paying. Yet on the AWS side, we are all on the same bare metal machine.
Okay.
So that shared infrastructure, it's like an Uber. The way we were saying, different people are paying for that Uber daily. You rode from here to there. I moved from point B to point C. So it's different people who are paying for the infrastructure, but it's owned by AWS, and that means cheaper costs. Coupling with those discounts for acquiring this infrastructure at large scale, cheaper costs will also come to our end. Another thing is high availability, and this is because of the AWS global infrastructure. The global infrastructure enables you to be highly available. Imagine, Isaac, you and I have got an e-commerce website, but most of our business is not even in Kampala. On the AWS global infrastructure, we are leveraging on it, and we are using CloudFront and what we'd call an edge location in London, which is Europe West, let's say the Europe West region. And the people who consume most of the matoke you and I sell online are people who live in South London.
Okay.
You know, we can host this particular e-commerce website you and I are running, and we have ensured that it's doing content delivery in Europe West London. And every morning at 3, you and I put some matoke on the plane. It's sent to our warehouse in South London, and the delivery guys do the delivery. Without AWS, do you think that business model would have been possible for us? It would have been hard, because there's even latency issues. Imagine we were hosting the website on a bare metal machine in our basement somewhere in Kampala. You know, there can be so many issues. But this e-commerce website will be highly available because we are hosting it on the AWS global infrastructure. We know our client base is South London. For that reason, we are ensuring that the website is highly available in the US West London region. I mean, Europe West region in London. And this makes sense. And also replicating data to multiple regions on that global infrastructure of AWS is possible, which was not possible before. I mean, you and I cannot afford to set up a data center in each continent. But thanks to public cloud and AWS, now that is possible. Then security. This one, you can take it to the bank. I know IT people love security issues, but this one, you can take it to the bank. You see these public clouds, they are more secure than those on-prem data centers you run. Isaac, why do you think, why is it when we go do that audit, we always find the public cloud, whether it's AWS or Azure or OCI or any of them, is more secure than your own on-prem data center? Why do you think that is so? Isaac, if you're speaking, you're on mute.
I think the security component is paid. They pay a lot of attention to the security setup. That's why they're more secure than the on-prem data centers.
What makes them pay a lot of attention to security? What do you think makes them pay a lot of attention to?
Because of hackers?
Yeah, that's of course a threat that is there even on-prem. Yes, there's hackers. I don't doubt it. Let me help you here. It is because they comply to very many security standards. Do you know what the consequences would be for AWS getting hacked? Let's say in the US. Do you know somebody will go sue them?
Yes.
So there are government standards that AWS complies with. Then there are also industry standards. Then there are just general compliance standards. For example, If you are doing, let's say, IT that relates to health records of people, let's say you have a solution that is handling the health records of people.
Okay.
The US, you must comply to a standard that is called HIPAA. It's a government standard. It's not even me who's setting it up. So long as your application or your website or your solution is in the US and it's handling, what is it? Health records, you must comply with HIPAA. Now, this is to you. If you're operating with somebody who is in the European Union and they are requesting you to process their data in Uganda, never do that. You'll be prosecuted. Why? Because the European Union's GDPR must be adhered to. If you are in the US and you're dealing with data that deals with finance, you must comply with an act called the Sarbanes-Oxley Act. If you are handling, normally, Isaac, you use your credit card, you use your debit card, and so on and so forth. I know you paid for your ticket and you came to visit me in Nairobi. I'm willing to bet you used your credit card. Isn't that so?
Yeah.
Anybody who processes pay card industry issues must comply with PCI DSS. Isn't that so?
Yeah.
Otherwise, you will never be allowed to process a payment. Isn't that so?
Sure stuff.
Now, AWS complies with all that and more. AWS, Azure, all these people. Now, if we were in our own data center and we want to comply with all that, do you think it will be easy? Will be our work governance and compliance, or will our work be to give IT services to our people?
And that's all. You don't have an external eye just to make it to enforce those compliance standards within an organization. So you don't pay attention to all these.
Now, can you see being compliant with various standards? Some are international, some are industry-based, some are country-based, and AWS complies with them. Are you understanding why the public cloud is far more safe than your own data centers?
I understand it now.
Yeah. So it's a very secure environment. So those are the things that this examiner is going to ask you about, that if you don't know, you are in trouble. If you don't know these, on-demand resourcing, scalability, economy of scale, flexibility and elasticity, growth, utility-based metering, shared infrastructure, high availability, security, if you don't know that, you'll mix one for another. You must be able to name and identify what that is.
Yep.
So let's look at cloud service models as we try to run towards the finish line. And we have already looked at this. No, we didn't look at this. No, we only looked at public, private
models.
Now, as a service model, I already told you there's the so-called client-server architecture. And the cloud shines where the client-server architecture is concerned. There's always a server that is giving a service. But we have the service models, and the three prominent ones are infrastructure as a service, platform as a service, and software as a service. And the as a service model is prevalent in the cloud. We have even database as a service. We even have security as a service. We have function as a service. This, that, everything as a service is a very, very prevalent model in the cloud. Okay. So, Isaac, what do you know about software as a service? Tell us. These are things I think people are always saying. What do you know about SaaS, or software as a service? This one is the most common one and all of you use it.
The email?
Yeah, like which email? Which email do you know is software as a service?
Gmail.
Yeah, Gmail. You see, here with software as a service, how did you open? Tell us how you opened your Gmail account, Isaac.
I just went to Google. Back then in the days, it's been a couple of years, then put in Gmail, then I went through the process, the steps of setting it up.
What were those steps? You were registering, eh?
Registering, yes. Like my
and
name.
Ever since you registered, have you ever done any other thing other than use it?
Nothing else.
So it is the simplest. you have no control over the service. All you ever do is to just register and use. So not only Gmail, Outlook, etc. Even we have things like Dropbox. Do you ever store your data inside Dropbox?
For now, a couple of files.
Yes, but even this one, you only put there a registration email and you open that account and then now you upload your data there. Isn't that so?
Yes.
That is what we call software as a service. You have no control. Like if the Gmail servers broke down, do you ever go there to configure or troubleshoot anything? Never.
Never.
It's just your work to consume. That is software as a service. So you can even see it's Gmail that's being used as an example here. Then we have platform as a service. Typically, I put it to you that when maybe we make, for example, a website or a web application, let's talk about a website. The web developers would create the website. They code it out and then they will compile the code. And then if it is in a typical corporation, they'll go to the system administrators or the cloud engineers. The data center engineers and say, hey, we want to host this website for the company. And then provisioning for that particular website will be done. And then it can be hosted on a particular server. But platform as a server has enabled the devs, the developers, to be able to just write code, compile that code, and upload that code in a particular service in the cloud. And that that service will set up the infrastructure to support that supports the particular website. It will decide how many instances they want, maybe even if we want like an auto-scaling group for it. All the web developer has to do is to upload the code. A typical service here in the AWS world, we call it Elastic Beanstalk. Many developers, their work and their interfacing with the data center engineers has been taken away because they can write and publish their code, upload that code into Elastic Beanstalk, and then it will set up the infrastructure. A similar service on a separate cloud. Do we have any developers in the house, Isaac? Are people there familiar with a cloud called Heroku?
Yes, we have developers on the call.
Are there developers who know about Heroku? Is a Heroku cloud? It's very popular with web developers. They've got services like DigitalOcean and services like Droplets. All you need to do is to just write your code. Once you go into the Heroku cloud, you will set it on their platform as a service, and it will set up the infrastructure. The instances, the instances that need, the virtual machines that need to host that website, the auto-scaling, the infrastructure around provisioning for that particular website will be provisioned. So that is what platform as a service is. In a big way, it makes the work of developers easier, because developers, they are not about hardware, they are not about infrastructure, they are not about what is the best operating system to run on this virtual machine. So platform as a service enables them to achieve that. Then as we wind up, we've got infrastructure as a service. You remember we began with saying that these virtual machines, you can set them up inside the cloud and we call them instances.
Yes.
Now, when you set up these virtual machines, these instances, it is your responsibility to choose an operating system for them. It is your responsibility to configure security on them. If there's a software update, it's for you to do the patching. So that is infrastructure as a service. You have more control over the resources. And there are things that AWS will not. If you set up an EC2, which is an instance or a virtual machine inside the AWS cloud, you are the one who chooses the operating system you want on it. You are the one who chooses what security group you want this virtual machine or instance you set up to be in. Whatever applications you want on it, that's your headache. So you have more control over the virtual machine, and for that reason, that is infrastructure as a service. I don't know if that has made sense where our service models are concerned.
Yeah,
so
it has been.
As I was saying, these three are the most popular infrastructure as a service, platform as a service, and what is it? Software as a service. But the as a service model, the client-server architecture that this very old scientist, von Neumann, set up, it is very prevalent in the cloud. So you can have database as a service. I mean, you see, look here, even this disaster recovery as a service.
As a service.
Communication as a service, monitoring as a service, and so on, even functions as a service, and so on and so forth. Even you and me and you, Isaac, now, we can set up training as a service here on the cloud. And then we dish it out and make people pay, yeah? So those are the cloud service models: infrastructure as a service, platform as a service, and the software as a service. Huh? So as we wind up, we want to look at what are the common use cases of cloud computing. Migration of production services. We have our on-premises solutions inside our data center, and we have decided we've had enough. We also want to migrate into the cloud like every other person. So this is one use case that is very popular. Even the client I'm working with right now for their training, they've migrated their entire data center to the cloud. That was last month, but one. And then last month, they also migrated their ERP. You're familiar with ERPs, my good friend Isaac?
Yes. The project planning tools.
Yeah, so they migrated their SAP. There's a very popular German ERP, SAP. So they migrated their SAP to the cloud. And since these are on-prem engineers who know nothing about the cloud, we've been doing the similar training as I'm doing with you for them, such that when we sign off from the project, they know how to operate in the cloud. And why? I mean, why? They want cheaper costs. They want their organization to be more agile. They want all those good things that the cloud has to bring. Another one is traffic busting. We already talked about the complication of even buying one bare metal machine. But now it happens that maybe it's a time, like let's say we were running maybe an e-commerce website here. And then it is Easter or Christmas, and the workload that is coming against that is very big. So we can scale out. Instead of one, we can have these three running, and they're handling the workload. You see here, it's like Christmas shopping. And Christmas shopping has gone haywire on our e-commerce website. Orders are coming in like you can't imagine. They're about to break the website. If the website is hosted in the cloud, we can burst that traffic onto far more resources. And these extra virtual machines can help handle that workload. So traffic busting is one way that we can utilize the cloud. Another one is we can run our backup and disaster recovery in the cloud. It is a very, very, very powerful, powerful use case. Last month, GCP and Google nearly get into very serious trouble. There was a client who had done backup and disaster recovery on the Google Cloud. Then Google accidentally deleted that backup. That client is a big client, not a small client, a big international corporation. But again, the cloud still helped them save themselves because the backup was here in one region, but they had replicated it also in multiple regions. So maybe it was in region 1, but they also replicated it in region 2, region 3, region 4. So when the person came to look for the backup here, he found it been deleted by Google. And then he complained, what's not happening? Where's our backup? Then Google apologized. You know what? We deleted it accidentally, but they used the one in region 2 to restore the one in region 1. Just like that. But can you imagine if you are doing your backup maybe just on a collocated destination, and then an earthquake hit that destination where that particular data center is? You are gone. So is it making sense why you should have another backup maybe the backup of your infrastructure and your whole IT infrastructure in the cloud.
Yeah, it makes sense.
Yeah, it does make sense because it just, you will restore from the cloud. Another one is web hosting. This one is popular. This one is very popular. Even people like I who would have never imagined having a website 30 years ago, we make them in, day out. And even the websites we make nowadays are very popular. Like I was telling you, Isaac, you and I can set up our e-commerce website and we are ministering to the culinary needs of the Ugandan community in London. And they are paying us pound sterlings. And we are even caching using network and content delivery. We have the website very close to them in the Europe West region, London. And they are putting orders and we are packaging our matoke every morning early, put it on a plane to London and delivering. That was a business model in the old world I was born in. Oh, you wish. But today we can receive orders from anywhere and still deliver on those orders. Isn't that so?
Yeah.
In a lot of businesses, I think, honestly, if you are saying you're a business and you don't have a website, you're not serious. You just stop whatever you're doing, honestly. Isn't that so? Every other person is on a smartphone. Every other person is on a laptop. Every other person is on a computational device. And you want to tell us you are not where your clients are. You don't have a website. And you're saying you're in business. We better take you to a mental asylum. They check you up. Huh? Then another popular use case is test and development environments. You see, it would be very difficult for us to do what? To go, we are the developers in this company, but we have gone to the bosses to say, boss, we need a new server. We cannot test this in the production environment. Of course, we can't test the software in the prod environment. Isn't that so? The production environment is used for daily business. Then we're telling them, you know, a server costs 2 million shillings, but we want to use it for test and development purposes. They just look at us and say, you want to spend 2 million Kenya shillings on just test and production server? You are not serious. But doesn't it make sense, my good friend Isaac, for us to say, we are going to be doing some tests and for our latest iteration of the software at the end of the month, and it might cost us $50. Huh?
Yep.
So we are asking that please allow us to set up an EC2, an instance in the cloud. We do our tests such that we ensure the quality assurance on that software we're building is good. This one they'll agree. But 2 million Kenyan shillings? No, never. Hell no. Hell to the no. Never. So the cloud has also become a very popular test and development environment. Then, related to test and development is what we call POC. I think, hey, Isaac, explain. I think you've been doing a lot of this in your life. What is a POC?
Yeah, we do them.
What is a POC?
Basically, a POC is just like to test out something before it goes like into the live environment, whether it works or not.
Yes. So you see, we have a new application. We have a new website. We have a new solution. We want an environment to do a proof of concept and present it to the management before management accepts it. Then they can say, okay, run that POC for 2 weeks. Are we going to buy dedicated servers for something like POC? No. The company can afford maybe $100 to be paid to AWS at the end of the month because we are doing a POC. But I don't see it giving us 2 million Kenya shillings to do a POC. That's a lie. That's just not happening. Our core business is not doing POCs. Our core business is to make a profit as a competitor.
Yep.
Then here is another. We are winding up, and this is another place where the cloud shines. Shines at a level you can't imagine. Brenda, if your mic is on, can you tell us what big data is? If Brenda is not there, Darius, help us with what big data is. What is big data? This thing has also become as popular as the cloud nowadays.
Can you hear me?
I hear you loud and clear. Carry on, sir.
Big data, I would say, what is big data? look at
You
data.
use it daily, but now defining it is becoming a headache. Eh?
I always manipulate data on a daily. But, I think I'll use.
So let me help you.
Okay, thank you.
Mary,
And
Terence, maybe I can try to
yes,
explain.
help us, Brenda. Tell us what big data is.
Okay, so from my own understanding, I think big data is having large sets of data that can grow over time.
Correct. And that can pose a massive headache. Isaac, I tell you, if we were to handle big data in our on-prem data center, big data will burst it. But let me give you the full context because I want us to wind up. This is where we are ending today, and the rest you'll get from the handout of this particular presentation. Let me tell you something, Isaac. I want to bring this big data story into context, and I want you people to help me. Like Isaac, you know, Twitter is used. I mean, Twitter is like a whole continent on its own rights, isn't that so? Like, how many billion users are on Twitter?
There are many. I don't know the exact number, but
I don't know, 1, 2, 3. You know, these things are very big. Facebook, Twitter, even WhatsApp, for example. So, Isaac, let me ask you a question. How many tweets have been posted in the past 1 hour worldwide?
Over 1 million, I think.
Do you know Twitter has to store those tweets somewhere?
Yes.
Brenda, let me ask you. How many pictures, I'm not even saying videos or audio clips, how many pictures do you think you guys have uploaded and sent on WhatsApp in the past 1 hour worldwide, in the entire WhatsApp sphere? Darius, I dare to ask you, how many videos have some socialites posted in the past 1 hour on Instagram worldwide?
In Uganda alone, even a million.
Uganda alone. We've not even gotten to Kenya and Tanzania. Can you see how big data is complicated? That thing can burst open but do you realize it has to be stored somewhere and it has to be manipulated and it has to be administered? So guys, that is the case of big data. And where I sit, here where I'm sitting, if you are to ask me, I just believe big data belongs only to the cloud. Only the cloud can effectively, because we say the cloud is elastic, isn't that so?
Yeah.
Facebook has got its own private cloud. Like let's say the data center, the EMEA, the Europe, Middle East, and Africa data center, the biggest one, which of course they are virtualizing a massive cloud on it, is in the Arctic Circle, but north of Sweden, Luleå. Google, I think my good friend Isaac, you've been very close to Google. You guys have another big data center in Finland, and definitely GCP is running on it, isn't that so? In the Arctic Circle there. So honestly, big data belongs to only a place called the cloud. In full honesty, that place, I mean, if we were to try to put big data inside our data centers, the thing will burst and explode. I mean, we will not be. So the cloud is a very ideal place for you to store big data. It's an ideal place for you to manipulate big data. Darius, I think you had your hand up. Again, we come back into the line of questioning before we wind up.
Yes, I was just trying to give an example of where we can use big data. Where I work, we operate a public Wi-Fi. So around 750 APs around Kampala. So those APs have information, they have data that they load. So we can't keep that data locally. So what we normally do is we upload it in GCP, which is BigQuery. So it's a big data tool that helps us manipulate the data. So we imagine these APs have been up for the last 10 years.
Look at that.
We can always dig up that data from it in case clients need it. Okay, I think I just wanted to elaborate a local.
Excellent. That is, Ray, you also have your hand up as we go to the questions in the chat. Ray.
Thank you so much. You've elaborated a number of examples where can I call them server-based use cases are made cheaper, made more reliable via elasticity, via. I'm interested in understanding how on the user end I can look forward to something like, instead of buying a laptop that has superior capacity, I am looking towards something that is a bit minimal, but can run my computationally intensive applications like AutoCAD. So, for example,
excellent. A very beautiful question, because I know AutoCAD from a GPU perspective is very, let's say AutoCAD, Blender, those type of applications are very greedy for resources in your computer.
And there are times when you're working on these normal pieces of ours and it's really giving you headache. So instead of like buying a new one, and there are solutions in the cloud that can help me with such kind of like use cases. Thank you.
Our good friend Isaac, we take this gentleman back to what we were saying is as a service model. There you will have to go for the services that are desktop as a service, and you will define the type of RAM, the type of SSD or hard disk you need for that desktop that you will be purchasing. Then this particular workload that your own machine here cannot handle, you will have to take it in entirety and run it in the cloud from that particular desktop as a service that you're consuming. It's there. AWS also has it. I know rendering those pictures for AutoCAD and Blender and those type of applications. Once upon a time, I used to be in digital fabrication. So I'm feeling your pain. I feel your pain.
Thank you. It's understandable. I'll try it out.
Ray. Is Ray still having his hand up from the last time?
No, I'm done. You've answered me. Okay. Thank you.
Now, I want to talk to this question. It is, can you please explain the difference between elasticity and scalability? They are closely intertwined. They're like twins because they work together in a big way. Scalability would not be possible if elasticity did not exist. The thing is, when we are talking about elasticity, we are saying that the resource is infinite. The resource is infinite. Like, let me give you an example of how infinite things can get in the AWS world. A single object being uploaded into an S3 bucket. And don't worry about what I'm saying, S3 and bucket and etc. When we have our good friend Junior coming week 3, she'll handle storage. A single object being uploaded into an S3 bucket can be as small as 0 bytes to as big as 5 terabytes. Now, Darius, not Darius, who is our friend here? Darius. I put it to you, Darius. Huh? Which laptop or even which workstation do you have with you that can handle even anything up to 5 TB? And yet we are talking about a single object. And yet an S3 bucket can have objects upon objects upon objects. To put things into context for you, Darius, imagine Netflix. You know, all those Netflix movies, you stream them from an S3 bucket that's hosted inside, or S3 buckets that are hosted inside, AWS.
Yes.
So can you imagine the amount of data that Netflix puts for all your series, all your documentaries, all your, I don't know what, the whatnots that we are always watching from that particular. So are you beginning to understand the elasticity concept?
Yes.
It is almost infinite. Those constraints that we had, where we were saying, we need a new server. And then management asked us, but how much will it cost? We said 2 million Kenya shillings. They tell us, go to hell. You guys, you're professional jokers. Huh? There's no workaround around that too. The cloud at very competitive prices, that's not a discussion anymore. And then you see this becomes a game changer in how business is done. Huh? Then I come to the last question. What are the key drivers that make AWS highly available? One of the assignments I want to give is called the AWS global infrastructure. The AWS global infrastructure starts from a simple data center. But what we are calling a data center, you remember we were saying is as big as, let's say, Nakivubo Stadium. That is very small to the AWS. And then you go into what we are calling maybe edge locations and local zones. Then you go into what we are calling availability zones within a region. Then you go into what we are calling a region. Like in Africa, we have Cape Town is a region. Nairobi is a local zone. But in Europe, there are far more regions, and North America, there are far more regions, and also South America, and even Middle East and Southeast Asia and Asia Pacific, Japan, they're also regions. So then we go into those regions. That global infrastructure, which I'll also give, global infrastructure, I'll also give as a reading assignment. These are things I'll push through to Isaac, and he'll share with you. So that is what the AWS global infrastructure is what AWS leverages on to give you HA, high availability. I don't know if I've effectively answered your question, Isaac.
Yes, you have.
So,
you have done it.
Ladies and gentlemen, I beg that we call it a day. The class will always be best effort. The teacher will always push the class as far as we can push, but I will also make good to make life easy on you. I'll also give Isaac a handout. Now, Isaac, harass me. I owe you 2 handouts. One is on this content that we are doing. By close of business tomorrow, I should give you this particular handout house, a PDF of this handout that I was using for delivery. Then 2 is a reading assignment on the AWS global infrastructure. I'll share those 2. Yeah, that is like a 5 or 10 page PDF that when you guys study on your own, it will help you make sense. So can we call this as our inaugural class? It comes to an official end here. Next week, I'll talk to Junior, Pauline Junior, such that if it's possible, we can start an hour early, but the hour early is optional, but it will be recorded. We can do a knowledge check and we can do a lab demo. And then after that, Pauline Junior comes when the hour ends for the class on, not Pauline, will be William, for the class on
William is coming in.
William will be coming on compute. And on compute, William is going to handle EC2, he's going to handle ECS, he's going to handle ECR, he's going to handle EKS, he's going to handle AWS Elastic Beanstalk, he's going to handle AWS Lambda, he's going to handle AWS Batch. Then it can flow into things like application load balancer, network load balancer, also classic load balancer and gateway load balancer, and that will be compute. That is what we are studying next week, but I'll give you the full breakdown by close of business tomorrow, Isaac. So far, maybe I can have a feedback round. I don't know if that was helpful. I don't know if that added value. I don't know if you want to improve a certain thing, or I don't know if you want to take away a certain component. Feel free to let me know, but also feel free to let Darius and Isaac and Brenda know, and we can continuously improve this such that we are giving you something that will expand your knowledge base and build your skill set, such that when you do the AWS CCP, you are sitting comfortably knowing that you're in the driving seat and you can drive us from point A to point B where AWS is concerned. So thank you for listening to me. And those very many remarks. Thank you.
Thank you so much, Terence. I think it's been a good start off that you've given us, grounding us. And I know for in terms of feedback, I think we shall get that feedback from the team during the course of today. The entire week, we shall of course have to relate to you. But from my from my end, thank you. We appreciate this and the entire team, and we look forward to having more of these. I know we have a compute by William. Then Pauline will come in. Then, as you said, on the final day, we shall have like 5 hours or 6 hours, where we call it like maybe essentials day, where we shall wind up everything, recap every concept and domain. So we call it a good boot camp. Maybe if there is any other person on the call here who has something to say, please. The time it's now. The floor is open. Any other business? Brenda, Darius, anything to add on? Any inquiry from anyone? Please feel free.
I can only say be consistent. Just don't give up. Study as little as 30 minutes a day. or as long as you can, just be consistent. You'll initially, I know for those with not with an Antec background, it will be strange. Oh, the teacher is saying S3, EKS, blah, 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 blah.
Yeah.
Soon you'll get the hang of it. You'll be spewing all that jargon even more than I do. Don't worry about that. Don't let it even give you mental torture for 1 minute. If your resolve is you want to do 30 minutes daily, your resolve is 2 hours daily or 1 hour daily, just do that. It's a journey and we are building up. You will be shocked. By week 6, you will be so knowledgeable. You will be shocked at. The thing is consistency. But if you are coming to class to rely on what Isaac delivers, what Terence delivers, I swear to you, on Monday you've forgotten everything. And then again, Saturday, you are hearing people talking of more jargon and like, okay, then again you forget. It's a time sink. It's a waste of time. But on your own, as we have discussed with the moderators, let us commit to doing something, maybe daily, weekly. By the time our weeks end over here, you will see that you have a very solid knowledge base. And if you are doing some practices on one platform or another, you'll also see you've built a skill set. And the thing is, AWS will have been demystified for you. So that is what I'll urge you. The students who have noted always come out very well and end up loving this technology and thriving in it are the ones who've made that resolution that, you know what, I only have my lunch hour, and my lunch hour, I only give it 30 minutes daily. And they're religious to that. Or maybe I always wake up only 1 hour in the morning, I give it 1 hour. Just stick to your resolution, and you'll find that this thing becomes easier as the days go by. But if you're waiting at, okay, we will do 4 hours or 3 hours with the class on Saturday, and then again we disappear, you will become a Sunday Christian. We only appear in church on Sunday. And then those other days, Monday until Friday and Saturday, we are doing different things. So yeah, that is my exhortation to you.
Thank you so much, Terence, for those words of wisdom. And I believe that everybody on the call here will take them. So that's at the end of it all. We are better guys in cloud computing. I think that's it. We are good to end this for today and see you next week on Saturday, same time. So though you said that earlier, so for the guys who can make it early enough, that's at 10. Shall be communicating with
we'll do a knowledge check. If you make it earlier at 10, we can do a knowledge check on compute, because I'll have given you the handout, the PDF, you've read it, you've done the assignment, you've read the global infrastructure. Then we can test ourselves. You know, it's one thing to study, but it's another thing to go test a knowledge check and say, hey, am I understanding what we are studying, or am I just having loopholes in my comprehension? So we'll do a knowledge check of about 15 or 20 questions. And then we'll do a console demo, and then after that we say, okay, that's good enough, and we give William a chance to teach us computer.
Okay.
All right. See you when you see me. Have a restful weekend. God bless. Take care.
Bless you too, and have a good week ahead.
Okay, bye-bye.
Thank you. God bless you too.